This lecture is going to cover 1.7, negation of compound statements. So this is the last section in chapter 1. And what we're going to have is the negation of a disjunction, the negation of a conjunction, which are going to be De Morgan's equivalences. And then we're going to have the conditional negation equivalence and then the biconditional negation equivalence. So that's what we're going to cover in this section. So it's going to be negations. So first, let's talk about the negation of a disjunction. So if we need to negate an or statement or a disjunction, we would write not P or Q, right? That would be the negation. So when we use De Morgan's equivalence to negate the disjunction, it tells us that in order to negate a disjunction, we just negate both components and change the or to an end. So De Morgan's equivalence states that not P or Q is equivalent to not P and not Q. And I'm not going to do this for all the equivalences, the negation equivalences that we're going to look at in this section. But at least for the first one, let's make a truth table just so you could see that they are equivalent. Because sometimes it's hard, when you tell students, okay, here, just memorize this. Not P or Q is equivalent to not P and not Q, and just take it for what it is. But a lot of times I like my students to see, okay, that they are equal and why they're equal in terms of, their truth statements, the equivalency. So let's make a truth table to show that this De Morgan's equivalence holds true. So why don't we make a column for P? We have Q. We have a not P, a not Q. And then we have P or Q, and then we have to negate P or Q. And then we have not P and not Q. So let's fill in P, Q, not P and not Q, so that we should be pretty quick at by now, right? And P or Q, right? So let's look at P or Q. So the first two columns, we're going to look at the disjunction. And remember, the disjunction's always true if there's at least one true. If both are false, then the disjunction's going to be false. So we have true, 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 but here we have a false and a false. So that's going to be false. Now let's negate P or Q, right? So that's this column right here. So we're going to look at the previous column and just negate. The trues become falses, and the false becomes true. Now last, we have not P and not Q. So let's take the conjunction of not P and not Q. And a conjunction is only going to be true if both statements are true. So we have false, false, which is false, false, true, which is false, a true, false, which is false. And then the last one is true, true. So that's going to be true. And now if we compare these last two columns, right, the truth values for not P or Q and not P and not Q, they're exactly the same. So that's why we have this equivalence, right? Because they're logically equivalent. So we can say that not P or Q is equivalent to not P and not Q. So let's just practice using De Morgan's equivalence. So let's look at A. So we want to rewrite each statement by using De Morgan's equivalence. So basically, I think of it as we're distributing the negation, right? And the or becomes an N. So not R or S is going to be equivalent to not R and not S. For B, we're going to have distribute the negation, right? So we're going to have not C or becomes and we have a not Q, which is Q. So we end up with not C and Q would be equivalent. Next, we have not M or K. So a not M is going to be M. The or becomes an and now we have not K. So M and not K. And then we have D, not G or not P. So distribute the not. So we're going to have a not G, which is G, or becomes and then we have a not P, which is going to be P. So we end up with G and P as the equivalent statement. So now let's just go backwards. We have the conjunction now, so let's write it as the or statement. So to go the other way around, basically take out the negation, right? So it's like almost like we're factoring out a negative, kind of think about it that way. So we're taking out the negative and we're changing, right? So we're negating both the left and the right-hand side. So a not D is going to be D, the N becomes an or, and then change not B, right? So take not B, which is going to become B. So this is not D or B. So for B, we have not K and G. So we have to take out the negation, but then think about now we have to negate, right, each one of these simple statements here. So not K is going to be K. We have, or, and then G becomes not G. So we have not K or not G. And we'll do one more. So we have to, because remember, De Morgan's equivalence is when we negate an or statement, right? So we have to put the negation in front, and what are we negating, right? To end up with an N and then an R. So it would have to be a not N or a not R, right? Because a not N is N, and then a not R is R, and the or becomes an end. And let's practice one verbally. So write the negation of I will be the designated driver or I will drink. So first let's symbolize this statement as is. So I will be the designated driver, which will be D, or disjunction I will drink, which K is underlined, so we'll use K for that simple statement. So D or K. Now let's negate this statement. So it's not D or K. And that is just De Morgan's, right? We could apply De Morgan's equivalence because we're negating a disjunction. So this is going to be not D or becomes and then not K. And in words, this will be, I will not be the designated driver and I will not drink. So that would be the equivalent statement. I will not be the designated driver and I will not drink. So now let's look at the negation of a conjunction. So now we're going to negate an and statement. Up above, we were negating an or statement. So we still call this De Morgan's equivalence, but now we're negating the conjunction. So in other words, not P and Q. And I'm not going to write out a truth table for this one like I did above, but if we were to write out a truth table, we would see that not P and Q is equivalent to not P or not Q. So very similar to above where I did that up here, right? We showed that not P or Q is equivalent to not P and not Q. If we were to write the truth table for these two statements, they would hold the same truth values all the way down. So let's practice using De Morgan's equivalence now, but for a conjunction. So look at A. So in A, we're negating this conjunction, D and not R. So I think about it as distributing, right, the negation. So this is going to be not D and becomes or. And then we have a not R, which is going to be R, right, the double negation. So we have not D or R. For B, we have not Q and S. So a not Q is Q and becomes or, and then we have not S. So Q or not S. For C, we have not J, which is J, or N becomes or, and then a not W is W. Now let's practice going the other way. So now we have the result, right? We have the or statement. So let's write the end statement that was negated, right? So we have to start with the negation. And what was negated? Well, now we have to write the opposite of not P and not S. So that's going to be a not P, which is P, and not S, which is S. So not P and S. For the next one, we have Q or not R. So what did we have to negate to get that? What conjunction? Well, negate Q, so that would have been a not Q, negate not R, so not R is R. So not Q and R. And then we have H or G, so we would have negated not H and not G. So that's how we apply De Morgan's equivalence for a conjunction. And now let's just practice. So exercises 1 to 10 here. Let's use De Morgan's equivalence to rewrite each statement. So let's just write De Morgan's equivalences down here, right? So we have either not P or Q. That's equivalent to not P and not Q. And then we have not P and Q, which is equivalent to not P or not Q. So those are my two De Morgan's equivalences. So for number 1, we're negating a disjunction. So we're going to have not P and a not Q, which is going to be Q. For number 2, again, we're negating an or statement. So we're going to have a not W, which is W, or becomes and then negate the S, so not S. So we end up with W and not S. Number 3, again, we're negating a disjunction. So we're going to have not P, which is P, or becomes and then we have a not S, which is S. So P and S would be the equivalency. Number 4, we're negating an and. So we're going to have not B and becomes or, and a not R, which is R. So not B or R. For number 5, we're negating a conjunction. So not A is A. Whoops. Let me just write equivalency sign first. So we're going to have A and becomes or, and then negate B, not B. So A or not B. For number 6, we're negating a conjunction again. So not Q is going to be Q. And becomes or, and then we have not S, which is S. So Q or S. Now for 7, 8, 9, and 10, notice there's no parentheses. So De Morgan's equivalence was already applied, right? Then think about it as the negation was already distributed. So now let's rewrite it as an and or an or statement that was negated. So now we're just going backwards, right? Because we don't have the negation in front of the grouping, the set of parentheses. So now we're going the other way. So remember how we did it above. So it's like, what are we negating? So take the negation out, right? And a not Q is Q, or becomes and a not D is D. So that's equivalent to not Q and D. Let's do the same thing for number 8. What did we have to negate to end up with C or not K? So start with the negation symbol, then parentheses. So negate C, so we have not C, or becomes and now negate the right-hand side, not K, so a not K is going to be K. So we have not C and K. For number 9, we would have had to negate not M, which is M, and was an or, and then a not N, which is N. So we negated M or N. And then we'll do one more. So for number 10, we had to negate not A and becomes or, and then not S. So this is the negation of not A or not S. So that's how we use De Morgan's equivalence to rewrite either conjunctions or disjunctions. And these equivalences are on that sheet that I pointed out in the last video, and it's also posted in this week's lesson. So it's within, after, I think it's at the end of the worksheets and the videos, and I called it equivalences. So let's practice one in words. So negate the following statement. I will take you to dinner and the movies. So let's symbolize first. So this is a conjunction, right? So I will take you to dinner is D, and I will take you to the movies, which is M. So D and M. Now we want to negate that statement. So the negation of D and M. If we use De Morgan's now, because that's how we negate a conjunction, this will be not D or not M. And in words now, because this is an or statement, right? So it's going to be either I will not take you to dinner, or I will not take you to the movies. So either I will not take you to dinner or I will not take you to the movies. So that would be the negation of I will take you to dinner and the movies. So De Morgan's is what we use when we negate a disjunction or a conjunction. In this next section, we're going to negate a conditional statement. So if we need to negate a conditional statement, we're going to negate P implies Q, right? So we'd have the negation symbol in front of P implies Q. So we have what's called the conditional negation equivalence to negate that statement. So to negate a conditional, that would be equivalent to P and not Q. And again, just in the essence of time, I'm not going to write the truth table to show you that, at the end, these two statements, the columns for these statements are going to have all the same truth values, and it is going to be an equivalence. If you want, you could do that on your own. You should definitely be able to do that. But if we were to make a truth table, you'll see that these statements would have the same truth values. Therefore, they're equivalent. So the negation of a conditional statement is logically equivalent to a conjunction with the right-hand side being negated, right? So the negation of a conditional is going to be a conjunction, and the right-hand side becomes negated. That's what this is saying. So an easy way to remember this is leave and negate. So leave the left-hand side, conditional becomes and then negate the right-hand side. So leave and negate. So let's practice. So use the conditional negation equivalence to rewrite the following statements. So for number 13, we're negating M implies B, that conditional statement. So leave the left-hand side, and right, the conditional symbol changes to an and, a conjunction, and then negate the right-hand side, so not B. So M and not B would be the equivalent statement. Number 14, we're negating the conditional statement, not S implies W. So leave, not S, and negate the right-hand side. So we're going to get not S and not W. Number 15, we're negating Q implies not R. That's going to be equivalent to the statement Q and, so leave and negate the not R. A not R is R, so it's Q and R. Now let's go the other way around. For 16, 17, and 18, it's already written as a conjunction, an end statement. Let's write the conditional that would have that we have to negate in order to end up with that. So this is the negation of, now remember, we leave the right-hand side, so it's going to be A. It's a conditional statement, right? And then we changed the right-hand side, so it became not D. So if we negate not D, right, it's going to be D. Not D is D. So this is not A implies D, is equivalent to A and not D. Let's do the same thing for number 17. So what conditional did we have to negate to end up with not K and C? So leave and negate, right? So the left-hand side never changed, so it was not K. And right becomes a conditional because we were figuring out what conditional did we have to negate to get this end statement. And we negated the right-hand side to end up with C. So what's the negation of C? It's not C. So we're negating not K implies not C. And we'll do one more. Look at number 18. So what conditional statement was negated to end up with not Z and not Y? So it's not. Now, we never changed the left-hand side, so not Z. And then we have the conditional statement, right? But the right-hand side changed to not Y, right? So what's a not Y? It's going to be Y. So not Z implies Y. And let's do one in words. So write the negation of, if you get sick, then you should quarantine for 14 days. So first, let's symbolize this sentence using symbols, right? Logic symbols. So if you get sick, then you should quarantine for 14 days. So we have the simple statement, if you get sick, and the other one is you should quarantine for 14 days. So we're using S and Q, and it's conditional, right? If, then. So if you get sick, then you should quarantine for 14 days. So S implies Q. Now we want to write the negation of this statement. So let's negate the conditional statement, right? Because that's what I'm asking you to do, write the negation of this statement. So this is just going to be the conditional negation equivalence, right? So remember, leave and negate. So we're going to leave the left-hand side, which is S. Conditional becomes and let's negate the right-hand side, negate Q. So we get S and not Q. And now let's put that in words. So remember, we can either write and or but. And and but are the same thing for the conjunction. So this sentence is, so for S, you get sick. But, or and if you want, not Q, which is you don't quarantine for 14 days. So the negation of that conditional statement, if you get sick, then you should quarantine for 14 days, is you get sick, but you don't quarantine for 14 days. And then the last example is just showing that sometimes you need to use more than one equivalence to negate something. So what I mean by that is, look at A. So for A, we want to negate the or statement, right? We're negating G or K implies M. But the big picture, if we look at the big scenario here, we're negating an or, and that's De Morgan's, right? So you don't have to write it, but I am, just so when you go back and if you want to review this, you could see the thought process, right? So that's De Morgan's. And you know what? Let's write them here just so we have them again in front of us. So for De Morgan's, we either negate the disjunction P or Q, right? And that's equivalent to not P and not Q. Or we could negate the conjunction, which is not P and Q. And that's going to be not P or not Q. And then we have the conditional negation equivalence. And that's when we negate a conditional statement, right? Not P implies Q. And that's equivalent to, remember, leave and negate. So that's going to be equivalent to P and not Q. So for A, since we're negating an or statement, right, we're going to use De Morgan's. So this is going to be not G and not K implies M. But within this, we could use another equivalence, right? Because look, we're negating a conditional. So we're going to have, so this is the conditional negation now. So I'm going to have not G, and now let's use the conditional negation equivalence here. So we're negating this conditional. So remember, leave and negate. So that's going to be K and not M. So the result is going to be not G and K and not M. So let's look at B. We're negating a conjunction, an end statement. That's the big picture here, right? We're negating an end statement. So that's going to be De Morgan's. So with De Morgan's, we're going to have a not D, which is going to be D. and then N becomes or, and we're gonna have not P or not N. So we're negating the right-hand side, right? Not P or not N. But look what we have. We still have inside here the negation of a disjunction, the negation of an or. So we can apply De Morgan's again. So we're going to have D or, let's negate P or not N. So that's going to be not P and a not N, which is N. So we end up with D or not P and N. Let me just make that look more like an N. For C, look, we're negating a conditional statement now. So we're going to use the conditional negation. So remember, leave and negate. So we're going to have not P, and now let's negate the right-hand side, which is Q and R. So we're going to have not P and Q and R. So this was the conditional negation equivalence. But now you'll see on the right-hand side of this conjunction, we're negating a conjunction, which we could use De Morgan's. So we're going to have not P and let's use De Morgan's for the not Q and R. So that's going to be not Q or not R. So we end up with not P and not Q or not R. And we'll do one more. So for D, we're negating a conditional again. So we're going to use the conditional negation equivalence. So leave and negate. So we're going to have, so if we use the conditional negation, we're going to have W and now negate the right-hand side. So not A implies not S. But if you look at the right-hand side, we still have the negation of a conditional, right? Not A implies not S. So we could use the conditional negation equivalence again. So we're going to end up with W and let's negate this conditional, right? So leave and negate. So a not S, which is S. So we end up with W and A and S. And that wraps up section 1.7 and chapter 1. So this last section went over the equivalences that, you know, contain negations. And you'll have homework to practice with this.